Okay, so today we are going to demonstrate how to run a statistical analysis in RStudio. So first of all, I'm going to show you the data that we're going to use. We have this data set of trees that we surveyed at Turkey Creek Sanctuary in Brevard County, Florida. For each tree, we have latitude and longitude locations of the tree, and we have NDVI values that have been extracted from drone imagery. So, and then we also have the species names of the trees. So we've got 30 data points, and we are going to try to determine if there is a statistically significant difference in tree species based on their NDVI values. So the first thing that we are going to do is we're going to check with normality within our NDVI values. So the first test we're going to run is going to be a Shapiro-Wilks normality test. The code for that is on line 2. And when we run that, we identify the p-value result from this test. In this case, the p-value is 0.3758, indicating that we do have normality in our data and we can proceed with a parametric test. If we had received a p-value less than 0.05, and indicating that we did not have normality in our data, we would choose a non-parametric test such as a Kruskal-Wallis. So in this case, we have normality, so we are going to proceed with our next step, which is to run an ANOVA test. So to set up the ANOVA, we put the response variable first, which is the NDVI value, and the predictor variable second, and that is going to be our tree species. So we run this test and we end up, and when we run the summary, that gives us our p-value for the test. And so as you can see, our p-value here is 0.00362. Anything less than 0.05 indicates that there is a difference in our variables. And so now we just need to figure out which variables are different. So to do that, we're going to run a post hoc test. We've chosen the Tukey's HSD test. And when we run that, we end up noticing that these are the values we're looking for, these ones in the last column. So we have 2 down here that have p-values less than 0.05. And so now we know that Q virginiana and Q laurifolia are able to be identified based on differences in their NDVI values. And also S. palmetto and Q. laurifolia are able to be identified based on differences in their NDVI values. And now this data can actually be used to be put into models, and we can make prediction now based on NDVI values, what type of trees may be found at certain locations.